Hello everyone, welcome back to Code Enzyme. This is the second video of this playlist and we are going to discuss graph coloring or bipartite graphs. Now this is also an important concept for competitive programming and I've seen quite a lot of problems on this concept. So what is graph coloring? Let me create a new page and make an example graph. So let's say we have a graph like one node is here. Not like this, yeah. So let's say we have a graph something like this, okay, and there is one more thing said in the question that we want to color every node. So the problem statement goes like we want to color every node to red or yellow. Let's say these are the two colors, okay. So we want to color every node red or yellow such that no two adjacent nodes are of same color. Okay, so we have this problem statement like we have to color every node either red or yellow such that no two adjacent nodes are of same color. Now what are adjacent nodes? Any two nodes that have an edge and that have an edge between them are called adjacent nodes. So let's try to solve this. Like what I can do is I can first color this node yellow, and obviously if this node is yellow, then these two nodes must be green, right? Not green, sorry, and these two should be red, right? So I will color these two nodes as red. If these two nodes are red, their adjacent must be yellow, so these two will become yellow, and this final node will become red. And if at the end, if you can actually form such a graph, there are three nodes of this color and three nodes of that color, and if I can form such a graph, then this graph is called bipartite. So this is the definition of a bipartite graph. So if you can divide the vertices in such that the adjacent are of different colors, then the graph is said to be bipartite. Now a case might occur that when we can't actually form such a graph, we can't actually divide the vertices into two groups, and in that case I have to check and say that it is impossible. Now let's see a problem statement that uses this concept. So the problem name is building teams, and this is from the CSES problem set. So let's first read the problem statement. There are n pupils in someone's class and m friendships between them. Your task is to divide the pupils into two teams such that in such a way that no two pupils in a team are friends, and you can freely choose the sizes of the teams. Okay, now let's see the sample input. So we know like there are 5 friends. So let's say we have 1, 2, 3, 4 and 5. Okay, so we have 5 friends, and there is friendship between 1 and 2. There is friendship between 1 and 3. There is friendship between 4 and 5. Okay, so I think so if you have watched the previous video, this whole thing represents a single graph, and a graph can consist of several connected components, right? So it might happen that there might be no friendship between this component and this component. Okay, so since let's color the first person as red. Okay, then automatically the second and third person should become yellow, right? And if this is the case, then okay, this component was at least colorable. And now for the second component, I can color one of the nodes as red and the other as yellow. So yes, this graph was colorable, and we can do this. Okay, now how do we go about coding this? So actually it is pretty simple. You can start a DFS from the first node, and if the color was not assigned, you can assign a particular color and then keep going DFS around it. So it is kind of a brute force, but yeah, that is the code. Now let's move on to the coding part. So I will just simply create a new file. So I will create a new file, and let's use a normal template. So I will remove the unnecessary comments. Yeah, and let's take the input. So the first line contains an integer m, the number of nodes, so int n, and the number of edges is m. Okay, So we have this, and now we want to take the graph as input. Now you can use a map of vector int, and then whatever you prefer, but I prefer vector of vector int, so I will make a vector of vector int for this case. Or maybe I can simply create a vector of arrays. Whatever you prefer, you can do that. Okay. Now for an range, so I'm using 1 based indexing, that is why I'm doing a +1, or you can even use 0 based, whatever you prefer. So let's say u and v, and c in u and v, and then I can say graph of u dot pushback v. Now this will be an undirected graph, because if 1 is a friend with 2, then 2 is friends with 1, right? So I can say, okay, graph of v dot pushback u. Now like, how do we go about this? First thing first, like let's say my answer will be stored in an array. So I can say group of n+1, 0. Now I will say, okay, 0 means that a group has not been assigned yet. So I can simply traverse in the array from 1 to n, and if group of I equals 0, then I will do something. Okay, and then I can simply print group of I. So cout group of I with a space. Okay, yeah. So we have this. Okay, I mean, can I print before? This is a serious question. No, I don't think this is the correct approach. I mean, it might give me a correct answer for now, but I don't think this is a correct approach. So let's comment it out for now. Okay, so if I have a group of I equal to 0, I can say, okay, if the group is not assigned yet, then let's assign this a group. So group of I equals to 1. Okay, and now since we are talking about connected components, we will solve this using a depth first search. So let's write a function for depth first search. So let's say function void, it will be a void function, and this is I'm making a lambda function here. So if you don't know about it, you can Google about lambda functions. So this is a function of void, and I will call it DFS. So and let's say I'm currently at a node. Okay, now obviously this person was assigned a group, right? Because I am going to call this like this, DFS of I. So obviously this ith person already has an assigned group. So if I am at a current index, then I have to go to the neighbors and assign it a group. So I can say for int child or neighbor, whatever naming you prefer, in graph of u, node. If this new node was unassigned, so I can say if graph of node equals 0, then what? Then I can say not graph of node, if group of node. If group of node is equal to 0, then I have to assign this a group. So clearly, like if it is 0, it means that nothing was assigned. If my current node has a group of 1, then I have to assign it a group of 2. If the current node had a group of had group equal to 2, then I have to assign it a group of 1. So I can shorten my code and say group of I think this should be child. Yeah, if the group of child equal to 0, then I can say group of child equals to 3 minus group of node. Okay, so if the group of node was equals to 1, then the child group will become 2, and the vice versa. Okay, and after this I have to run my DFS function. So DFS of child. Yeah, otherwise if this is not and while returning, like when my DFS was ending, I have to check for one more thing, that if the group of child plus group of node, the current person, is not equals to 3, that means that such bipartite graph will never exist. And if this is the case, I mean, like if both will become 1, then the sum will be 2. If both will become 2, then the sum will be 4. It will never be equal to 3. Okay, and if this is the case, then then a bipartite graph will never exist. So I have to print impossible. and I can simply exit my code with exit 0, or I can even write return 0. It will get out of this main function. Okay, so we did this, and after this I can run my for loop again and see out what group of I. Let's try to run this and see if it is working. Okay, there is one mistake here. This should be an M, not an N. Okay, so kindly correct this, and we will run this again and see if it is working. So yeah, it passes the test case again, and let's try to submit this and see if it gives us a correct answer. Yeah, so our solution got accepted, and I hope you were able to understand how you can divide the graph into bipartite graphs. So if you were able to do this, kindly like this video and subscribe to the channel, and let's move on to the next problem. Thank you.